Once again, class. So this will be our second part of the lessons on abstract reasoning and recreational mathematics. So for this presentation class, so I will be presenting to you on how we usually solve recreational mathematics, okay, as a form of entertainment. So if you're going to define what is a recreational mathematics class, so it's a mathematics that is being carried out for the purpose of entertainment only, rather than as an activity or as a part of the student's formal education. So sometimes, or most often than not, recreational mathematics involves mathematical puzzles and games. So some of these mathematical puzzles and games are, of course, your mathematical puzzles that involves computing, or sometimes you also have mathematical games or logic, even magic that has something to do with math, math and the arts, number theory, and of course, math humor to some extent. Now, if we have here the first example, okay, of a mathematical game. So, if you are asked to arrange the five square tiles being numbered -2, -1, 0, 1, and +2 into a plus, meaning you are going to add these digits so that the sum of the three tile column and the sum of the three tile rows should be both equals to 1. So in other words, you're going now to put -2, -1, 0, 1, and +2 here so that if you're going to add, the total is always a +1, both horizontally and vertically. Okay, so there are 8 possible ways here, of course, because you can rotate, you can flip, but what we are going to do here, of course, we can just have some few of the possible solutions. So this kind of a problem class, sometimes the best way for us now to solve this kind of a problem is to start by just doing something with it. You can just put any number, then you're just going to adjust the numbering, okay, so that if it will not be satisfy the given conditions, then you can just redo it. So think about what you needed to do to solve just one part of the problems, then you can just start doing it. So the best way for us now is to use trial and error technique here. So if I have to put here -2, then -1, 0, 1, and 2 here, then try to add. And this time, we have 0 plus 2 plus -1 is 1, which is correct. -2 plus 2 plus 1 is also +1. So this is a solution to this problem. And this is only one of the 8. So one way to find another solution is, of course, you can interchange, you can rotate, you can rotate now your numbers here. So the -2 will be here, the -1 will be at the bottom, 1 will be on the left, then the 0 will go up. So you can rotate this, okay, 4 times, and you will be having 4 different solutions. The other one is to flip, meaning you can interchange the positions of the vertical, -2 and 1. You can also interchange 0 and 1 by retaining the others, and still you will arrive at the same results. Okay. Now, these are other ways of having a solution. So we have another solution 2, solution 3. So you notice here that what we have is that the largest number, which is +2, is always at the center. While the -1 and 0 here, they are in one row or in one column, while the -2 and the +1 are also in either one column or in one row. So by observations, we can have this as our way of knowing the other solutions as well. So you notice here that these are the combinations that the largest number from -2 to +2 is always at the center, then the -2 and +1 will be at the same row or in the same column, while the 0 and the -1 will be at the same row or the same column. So if you're going to rotate this all the time, clockwise, counterclockwise, flipping it, then you will have other solutions as well. Okay, so this is just a mathematical game as we all know it. Another example of a recreational math is with the arts, okay? So art gallery problems involve finding an unmoving guard or guards who can see the entire gallery. So when we say unmoving, it means that the guard should always be on that fixed position. They cannot move around. Okay, so a guard is able to see any of the gallery that can be connected to its position by a straight line without intersecting any wall. So in this case, if there's only one guard here for this kind of the shape of the gallery, okay, there are two blind spots. Okay, so the guard, if the guard is located here, so the guard cannot see part here. So these are the two blind spots. So most likely, pwedeng manakaw dito yung mga arts. Okay, so where the guard cannot see, so there must be another guard to be added. So in this case, we can find, okay, so what will be the minimum number of guards that can be placed. So in this case, we can put the two guards in this part of your gallery, and the guard here can actually see the part here and some part here. And of course, the guard here can look out for this part of the gallery. So in this case, there will be two guards that are needed to guard all the arts in this kind of a gallery situation. So again, this is just a simple mathematical games that we can have. So other examples are like this. So the solutions of the problem class, if this is the case, is depending on the shape of your gallery or a polygon, but the relationship between the polygon's properties and the number of guards is quite tricky. So for example, two of these concave polygons can be guarded by a single guard, while the other one requires two guards. So can you tell which of these three can be guarded by a single guard and the other will be guarded by two guards? So if we're going to look at these figures, we can see that A and C can be guarded by only one. So if the guard is placed at the center, then the guard can always see any parts of the wall here. Okay, so only one guard is needed for A. For C naman, if you put the guard at the center, then the guard can actually look at this part here. So there is no blind spot. Okay, so that will be our solution. But for letter B, this is actually, we need two guards. And where can we put the two guards? So you can put the guards one here, the other guard here, or you can just put the guards here, pwede rin. Okay, closer to one, but I decided to put it here so that the guard can both see this part and this part here. And this guard can also see this part here, and at the same time, it can also see the part here. So we need two guards for this shape of a polygon for letter P. So this is, again, an example of a mathematical games. Okay, another example of a mathematical puzzle is this one. So this is more of a puzzle. What fraction of the pattern is colored yellow? So in other words, this part here of the yellow colored is what part of the entire figure. So we have only white and yellow parts. So if we're going to count the number of triangles perhaps, then how many triangles can we have in yellow? Then how many white triangles as well? Then we can just get the ratio, and that will be the part of the yellow triangle. So there are four identical yellow triangles, or squares rather, one white squares, and the rest are all triangles. So what we can do here, class, is we can divide this into similar triangles. So by doing that, we can easily see how many white and yellow triangles. Then by counting the number of white triangles, these are already similar triangles, and how many are yellow triangles, then we can do this already. So by counting how many white, how many yellow, so in this case, if you're going to count, so by adding some lines to the pattern, to give it an additional structure. So we can see already that the area colored yellow is equals to the area that is colored white. So they are exactly the same. So one way to do this is to simply count the number of white triangles and the number of yellow triangles. So we know here that if there are 1, 2, 3, 4, 5, 6, 7, 8, There are also 8 here. So there are 16 white triangles. And how many yellow triangles? There are also 8 yellow triangles. So in other words, we have 1/2. So 1/2 are yellow, 1/2 are white triangles. So going back to the question, how many or what fractions of the pattern is colored yellow? So because there are 16 white and there are also 16 yellow, so we have 1/2. So half of the triangles are colored yellow. Okay, so that answers our question, class. So other examples are like this, class. Ayan. So who won the race? This is the question. Suppose that in a race among Berta, Boris, and Bogart, we only know one fact is that Boris finished before Bogart. What are the possible orders for the entire race? So, what is assured here, class, is that Boris is always ahead or finished first before Bogart. So, si Boris mas nauna kay Bogart. So, we can have this as our way of rearranging them in such a way what are the possible orders for the entire race. So, we have here uh, more than one solution, class. So what is important is that Boris should finish first before Bogart. So if we're going now to rearrange them, is that remember that Boris finished before Bogart, so we can put Boris first before Bogart. And from here, we can now put Berta at the last one, and this could be one possible answer that Boris is the first, Bogart is the second, and Berta is the third. Now, is this another way for us to have this arrangement as long as Boris should finish first before Bogart? So we can have another solution. So what is important is that Boris should finish before Bogart, then we can put Berta in front of the two guys. And this is another solution. That Berta is the first, Bogart as Boris should be second and Bogart should be third. So we always notice, class, that Boris should always be ahead of Bogart no matter what. And is there another way for us to find another solutions? Yes, we have another one. As long as Boris should be ahead of Bogart. That is important. Then we could put Berta at the middle. Then this is another solution, class. So in this case, Boris is the first, Berta is second, then Bogart is third. Okay, so these are different ways to find out that the placement of Boris should always be ahead of that of Bogart. So either Boris should be first or Boris should be second. And Bogart is either the second or the third. It depends now whether Berta is the first or the second or the third. Okay, so there are other things that we can solve mathematical recreation problems here. Okay, so there are also other problems, class, that only we use only the concept of logic to answer such. Okay, so that's it. So thank you for your time and looking ahead, class, on our next lesson. So thank you and see you again next time, class. Bye bye.